after it. Here we go. Alright, number 31. Now, the first thing you do is you realize you have a polynomial function, so you write down the end character traits. Okay? So I have an odd degree with a negative lead coefficient, -1. Well, if you've memorized your information correctly, whenever the degree is odd and the lead coefficient is negative, that means it's going to rise to the left and go down to the right. Next, you want to write down the maximum number of turns that the function can take. Alright? So we have a degree of 3. Always subtract 1. Subtract 1 from the degree. So 3 minus 1 is 2. The max turns is 2. Alright? So when you graph polynomial functions, get into the habit of always writing this information down, okay? And now, by the way, you know something else too. I really did not mention this in your notes, but really it's a good thing to write down. Your degree is 3. So if I ask you to find the zeros, what's the maximum number of zeros this function can have? 3. So that means the maximum number of x-intercepts, the ditto marks, max x-intercepts would be 3. Okay? Alright, now, the next thing you do is you find the zeros of this function. Well, I've taught you before, when you're finding the zeros of a polynomial function, you're really finding the x-intercepts. If you're finding the x-intercepts, then you put 0 in for y or f of x. So let's put a 0 in here and we have this. Now I've taught you a lot of ways to find zeros. Try to factor for synthetic division, but this one here, oh my goodness, this one's so easy. We have no work to do at all. Think about it, guys. What's the only thing you can put in for x that would make this whole side become 0? 0. Nothing else. Think about it. Any number to the third power is not going to give you 0 except 0. If you put 0 in for x, you get 0 times 0 times 0, 0 times -1 is 0. So the only number that you can put in for x that gives you out a 0 is 0. So there we go. So the only 0 of this function is 0. So that means my x-intercept is 0. Now, I could have had how many? Sorry about that. I could have had how many x-intercepts? 3. But I only had how many? 1. Okay? Now, let's review. Step 1, write down all this information that you know about the function. It's going to help you when we start graphing in a second. Step 2, find all the zeros. We did that. Now, here's the next thing that you do. Your zeros tell you what to put into your table of values. Let me say that again. Your zeros tell you what x values to put in for x. So watch what I do here. I know the graph. I know the graph is going to cross the x-intercept or the x-axis at 0 right here. But what's the graph going to do over here? What's it going to do over here? And that's what I got to figure out, okay? So here's what we do. Our table of values should look like this. Watch my table of values. Copy this down, please. My table of values should look like this. Now look. Notice my 0 was 0. So I put a 0 right here in the middle. Then I went up how many numbers? 1, 2, 3. And I went down how many numbers? 1, 2, 3. Now, let me encourage you guys to use your graphers. Type this into your graphing calculator. Push the little button up at the top left that says y equals. And then enter this. Now don't hit a minus sign. Hit a negative sign. Then hit x. Then hit arrow. Then hit 3. And then go to your table of values. And the table of values gives you all of these values right here. It takes no work at all. Okay? So, let's review again. Write down the information that you know quickly. Find the zeros. Once you find the zeros, they kind of tell you what else to put into the table of values. we're going to do a problem like that, okay? But for right now, let's take it one little baby step at a time, okay? So now that you've put your 0 right here and you went up about 3 numbers, 3 or 4, whatever, down 3 or 4, and we filled our table of values, now we have a table of values that we can now put onto our graph. Let me slide it over here, erase all of this, pull this up, and let's get to work, okay? Alright, my first order pair is 3, negative 27, so I know it's negative 3, and way down here somewhere. Next is 2, negative 8, so 2, negative 8, 1, negative 1, 0, 0, negative 1, 1, negative 2, 8, and then of course way up here somewhere at negative 3. So I know the graph's going to look something like this. We're just sketching it, getting a basic idea, okay? Doesn't have to be perfect. It's going to come down here, take a little curve here, take another little curve, and then continue down. Now, by the way, polynomial functions never make sharp turns. They're always rounded turns. Always. Don't forget that, okay? Always. And so there we go. Now let's see if it fits our information. On the left side, is it going up? Yes, it is. On the right side, is it going down? Yes, it is. What's the maximum number of turns it can take? 2. Alright. Now it did not take any turns here at all. That's not a turn. A turn is when it comes up, it starts going down, then back up again, okay? Or actually a turn could be it comes down, hits right here, and can go back up. Those are turns, okay? But it could have, it can take no more than 2 turns, and we're fine. It didn't take any turns, that's fine. It's going up to the left, down to the right, and the maximum number of x-intercepts is 3. We have 1, so we're fine there. Now, Mr. Earhart, how do we know up here a little later it doesn't do a little dip-de-doo like that? That'd be 2 turns, and it's still going up to the left. You really don't know for sure, except that you can see how the values are getting higher and higher. So if you look at your table of values, it's just scroll through your table of values, and you will see, go to 4, 5, 6, 7, the numbers are going to get lower and lower, negative 27, negative whatever, it's going to keep going down, down, down. And as you go to your table of values, scroll up to negative 4, negative 5, negative 6, the values are going to get higher and higher and higher, okay? So it doesn't make any more turns, and that's it. That's a pretty nice one to start off with, guys. That's not bad. Let's try another one. Alright, here we go. The first thing we do is we write down the information that we know. It's an odd degree with a positive lead coefficient. Okay, so we know it's going to go down to the left, up to the right. Okay, now the degree is 5. Subtract 1 from that, and the max turns will be 4. Now my degree is 5, so the max x-intercepts would be 5. There we go. We're doing great. So we've written down all the information that we know about it. Now, next find the 0. So where the f of x is, put a 0. Now, once again, I've taught you pretty well what to do here. Synthetic division, factor, all that good stuff. But guys, don't jump to the hard stuff when it's easy. We don't need to factor this, and we don't need synthetic division. You know how to solve this very easily. Bring the 1 over and make it a negative 1. And now take the 5th root of both sides. The 5th root of x to the 5th is x. And the 5th root of negative 1 is negative 1. Because negative 1 multiplied 5 times is negative 1. Negative 1 multiplied 5 times is negative 1. Now, Mr. Harris, why didn't you put plus minus? We only put a plus minus when our index is even. 2, 4, 6, 8, 10, etc. This is an odd index, so we do not put plus minus. So there we go. We found the 0 just like that. We didn't have to factor. We didn't have to list out the possible rational zeros. We didn't have to use synthetic division. We just put 0 in to solve the equation. We're fine. So there's my 1 x-intercept, negative 1. So x-intercept equals -1. Now remember, your x-intercept tells you what the rest of your x values are going to be on your table of values, okay? So I have 1, 0, or 1 x-intercept, alright? And so notice I put my -1 right here in the middle because that's my 0, and I went up 3. 0, 1, 2, and I went down 3, -2, -3, -4. And that's it, guys. If you'll type this into your calculator, hit that little y equals button in the top left corner, and then push x, arrow, 5, then +1. And your table of values will look like this, okay? This is pretty simple, guys. It's not that hard. Alright? Alright, so we have written down our information that we know. We have found our zeros. There was one of them. And of course our zeros are our x-intercept. So I put my x-intercept right here. I went up 3 and down 3, and hey, we're good to go. Okay, so let's go ahead and get graphing here. Well, 2 is going to be way up at 33, so I'm not going to worry about that. 1, 2. 0, 1. -1, 0. -2 is way down here at -31. And +2 is way up here. So it's going to shoot way down here, so it looks like to me. I mean, think how low that would be. That'd be way down here. So even though I'm the worst artist in the world, hopefully you can still see. It's going to go almost straight down because it's supposed to hit down here. It's supposed to hit down here at 2. At -31. -2, -31. So we're going almost straight down like that. Alright, and then I'll come up here, take a little turn, or take a little curve, I should say. And it's going to shoot straight up because it's going to go way up to 233, so way up here somewhere. Way up there. Alright, almost like a straight line, but it's not. It's slowly curving to the right. And there we go. Now, I forgot and I erased my information. It's my fault, but and let me see something here real quick. Okay, students, I had to pause the video for a second, but what I was saying is I erased our information, but if you'll look, we had it going down to the left and up to the right. We had no more than 4 turns. It doesn't take any turns. No more than 5 x-intercepts. We only have 1, so we're fine there. And if you'll scroll through your table of values, you can see it continues to get lower and lower. And as you scroll up in your positive x values, the y values continue to get higher and higher. So this graph will continue to go up and continue to go down over here. Okay? Make sure you're following these steps and you'll be fine. Next problem. Now this one's very interesting, and I'm glad they gave you one like this because it takes you out of your comfort zone and makes you think. Because it's not written in standard form, and if you want to write this in standard form, you have to write this. No, don't write this down, just watch. Unless you want to, you can't, but you don't have to. You have to write x plus 2 4 times. Multiply the first 2 parentheses together, you would get this. Then multiply the last 2 parentheses together, you get this. Then multiply this trinomial times this trinomial. It's a lot of work. So we really don't know what the degree is. I mean, it's going to be a 4th degree, but I'm not going to get into knowing how to do that without doing all the multiplication. But we really don't know the degree. We don't know the lead coefficient, so we really can't talk about the number of turns. And we can't talk about the left and the right side, okay? So here's the best that we can do. Are you ready? We can write this like this. We're going to find the zeros. I'm going to write x plus 2 4 times. Now why would I do that? Because look, students, if I write x plus 2 4 times, oh my goodness, it's totally factored for me. Look at that. it's totally factored. So when I put 0 in for f of x or y like I'm supposed to, and then of course factor the left side, it's already factored for you. And if you take each one of those groups and set each group equal to 0, you get -2 for each group. So the only 0 you have is -2. That's it. That's the only 0 you have. Look, guys, you wrote the parentheses 4 times. There's no need to do all that multiplication and multiply everything out. We just need to find the 0, and it's -2. That's it, guys. We found our 0. Now, sure, we don't know what the end character traits are. That's true. We're not sure about the maximum number of turns. That's true. We're not sure about the maximum number of zeros. Okay, that's fine. Although I'm telling you now the degree is 4. But that's beside the point. I found my zeros. There's only one. It's -2. So I can definitely now take a table of values and fill it out without a doubt. Fill it out without a doubt. That's good. Alright, so my 0 is -2. So I put that right in the middle. And I went up 3 numbers. And I went down 3 numbers. And now all that you have to do is take your graphing calculator and type into it. Hit that little y equals button up top and then put parentheses x plus 2. Close your parentheses, then arrow, and then 4. Type that into your graphing calculator or into your grapher. And then go to your table of values and fill in these numbers. It's that simple. It's not difficult, okay? So having done that, we're now ready to graph the function. So here we go. Obviously 1 goes up to 80. Well, I'm not going to worry about that, but 0 is at 16. So let's shrink this a little so we have a little room to work. Okay? And here we go. That's 7. So, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, at 1, I'm up to 81. At 0, I'm on 16. At -1, I'm at 1. At -2, I'm at 0. At -3, I'm back up at 1 again. And at -4, I'm way up at 16. And then, of course, -5 is way up here. It looks like a parabola, doesn't it? That's exactly what it is, by the way. A parabola. So it comes down. It's a really skinny parabola. That's okay. Hits. Comes up. There we go. That's it, guys. Don't make this harder than it is. It's not that difficult. Write down the information about the function that you know. Now, in this case, we didn't know anything, which was fine. So next we found our 0s. There was 1 of them. So I put that in the middle, put in 3 other values going up, 3 other x values going down. Used my table of values on my grapher to fill this in and graph the function. It's not that difficult, guys. It's really not. Let's try another one. Alright, we have the same problem again. We're not going to be able to list out the maximum number of turns. We're not going to be able to list out the maximum number of 0s. I mean, actually, I can because I've done enough of these. I know how to look at these and tell. But right now, we're not going to worry about that. I also cannot tell the end character traits, okay, of the function. So I'm not going to worry about that. I'm going to go ahead then and find my 0s. So where the f of x is, I'm going to put a 0. 0 equals negative, and then x minus 3 to the 3rd power. Right? Now hold it. X minus 3 to the 3rd power means write this 3 times. There we go. Again, guys, it's factored for you. This negative sign here, you know what that means? You could look at it like there's a -1 here if you want to. It doesn't change anything. Remember what I've taught you, that when you factor an equation and then take each group and set each group equal to 0, I told you to only set the groups equal to 0 that have a variable in them. In other words, does this group have an x? Yes. Does this group have an x? Yes. Does this group have an x? Yes. But does this group here, -1? No, it doesn't have an x. No. So don't worry about it. not a minus sign, negative sign, parentheses, then x minus 3, close your parentheses, arrow 3, and there we go. Okay, so if you type that in, then go to your table of values, you can definitely fill this thing in correctly. Okay, alright, so we're ready to graph this. Let's go ahead and graph this. Alright, 6 is way up at negative 27, okay, but 5, 1, 2, 3, 4, 5 is at negative 8. 4 is at negative 1. 3 is at 0. I did that wrong, didn't I? Sorry guys, negative signs. Alright. 6 is at negative 27, so it's way down here. 5 is at negative 8. So 5 is down here at negative 8. 4 is at negative 1. 3 is at 0. 2 is at 1. 1 is at 8. And then of course 0 is way up at 27 up here. So if you scroll through your table of values, going to 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, these numbers over here in the y column will get lower and lower and lower, or smaller and smaller and smaller. Negative 27, negative 125, I think it is, and so on. If you scroll through your axis going 3, 2, 1, 0, negative 1, negative 2, negative 3, these values over here on the y-axis will get greater and greater and greater, okay? So it's not going to come down anymore. It's going to go up to the left over here. It'll come down, and it will not do that. There we go. Come down, make a little smooth turn here like that. Make a little smooth turn like that. Good to go. Okay guys, again, these can be challenging and I understand that, but don't make them harder than they actually are. They're not that bad, okay? Alright, moving on to the next problem. Okay students, number 41, here we go. Now, let's take our time and look at this. Alright, first of all, we have an odd degree and a negative lead coefficient. That means it's going to go up to the left and down to the right, okay? Secondly, my degree is 5, like I said earlier, so the max turns is 4. 1 less than the degree. The maximum number of x-intercepts would be 5. You do not subtract 1, whatever the degree is. It's the same number of possible zeros or x-intercepts that you can have. Now, we've written down our information. Next, let's find our zeros. Put a 0 in for y right here. And we're ready to find our zeros. However, again, there's no need to factor. There's no need to list out my possible rational zeros. None of that is necessary. Okay? If you'll look right here, you will see that all I have to do is bring the 2 over and make it a positive 2. Now divide both sides by a negative 1. There's a negative 1 here, even though you can't see it. And that would give you negative 2 equals x to the 5th. Now take the 5th root of both sides. The 5th root of negative 2. And the 5th root of x to the 5th. Of course, the 5th root of x to the 5th is just 5. X, excuse me. And if you type this into your calculator, you will get negative 1.2 rounded. So there I found my zeros. Remember, I did not put plus minus because it's an odd index. You only do that when it's an even index. And if you chose to put the radical in, now we chose to insert this radical. However, the degree of the index has to be even, and it's not. So there we go. So I found my 1 0. Now there can be more than that in the last problem we're going to look at, which is the next problem. We have more than 1 0, which is good, okay? Good practice for us. Alright, now, equals button, and then hit negative, not minus, negative, then X, then arrow, and then 5, and then minus 2. And then go to your table of values. You'll get this out right here. Okay? This is your table of values right here. So, with that in mind, let's go ahead and graph this thing. Now here we go. So let's plot our points. At 2, we're way down at negative 34. So I'm not going to worry about that one. 1 is at negative 3. 0 is at negative 2. Negative 1.2 is at 0 right here. Negative 2 is way up at 30. Way up at 30. And negative 3 is at 241. And negative 4 is at 1022. And if we put 3 into my table of values, let's see, that'd be negative 243, negative 245, I think. I did that in my head, so I'm not sure, but so at positive 3, you'd be way down negative 200, so it's not coming back up again, okay? So it looks like to me the graph's gonna, at negative 2 or way up here at 30, so it's gonna come down. It's gonna hit, kind of curve over a little bit, and then at negative 2, we're way down at 30 over here. It's gonna hit, and then kind of curve a little bit, and then pretty much go down like this. Okay, that's a pretty good picture of the graph. On the test or quiz, that would totally be sufficient, and I would look at your table of values too, to help me make sure that you understood what you were doing. Okay, alright. Moving on now to our last problem. This one's going to be a good one, so get ready, okay? Alright, number 1. I want you to write down the information that you know. Well, it's an odd degree with a negative lead coefficient. That means up to the left, down to the right. It's a third degree. Subtract 1, we get a 2, so max turns is 2. Max turns is 2. My degree is 3, so my max intercepts would be 3. At the most, I can have 3x intercepts. Alright? So I've written down all the information that I know about this thing. Now, let's find the zeros. Here's my f of x, we'll put a 0. Now this one's going to be a little bit of a challenge, okay? If I ask you to find the zeros of this, you know what to do. Students, my goodness, you know to always factor first. If you can't just solve it, like for example, if I just had negative x cubed plus 4, I'd bring that 4 over and make it a negative 4, and then divide both sides by a negative sign, and then take the cube root of both sides, and I'll be done. But the problem is I don't have positive 4 right here. Not even close. I have positive 4x squared, okay? So I'm going to have to either factor it, and if factoring doesn't work, I'm going to have to list out my possible rational zeros, and then use synthetic division. Which no one wants to do that, but sometimes you got to do that. But again, let's do factoring first. Maybe that'll help us, okay? So when you factor, you always pull out what's common first, okay? Here's what I've taught you. I've always taught you that pull out what's common. I have a 1 here and a 4 here. What goes into 1 and 4 evenly? Nothing but 1. That's not going to help. How about x's? I have 3 x's in this term and 2 x's in this term. So I can take 2 x's out of both of those. So pull out an x squared. However, I've taught you that when your first term is negative, also pull out a negative sign too. Always. So not only am I going to pull out an x squared, I'm going to pull out a negative x squared. Now, negative x squared times x gives you a negative x cubed, and negative x squared times a negative 4 gives you a positive 4x squared. Here, check it and see, guys, look. Negative times a positive is negative. X squared times x is x cubed. Negative times a negative is positive. X squared times 4 is 4x squared. So I factored it. Now, can I factor this some more? It's a binomial. Well, let me ask you a question. Do I have perfect squares or perfect cubes? I do not have perfect squares. Now this is a perfect square here, but the x is not. Now if that x was x squared, then yeah, multiplied by -1 is still 0. Now take the square root of both sides. You're welcome to put plus minus 0, but really plus minus 0 is just 0. The square root of 0 is 0. Bring your 4 over and make it a positive 4. X equals 4. So finally I have a problem with more than one x-intercept. So my two zeros, or my two x-intercepts, are 0 and 4. Okay? Now, before I put a table of values up here, which I know is, what we normally do, I want to show you something. In all the past problems, I had 1, 0, remember? So I just simply had to put that 1, 0 in the middle of the table of values. Now I've got 2. So take a look at it here on a coordinate plane. I know the graph's going to pass through 0 right here. I know the graph's going to pass through 4 right here, correct? So I want to put in some values over here to the left of 0. I want to put some values in between my two zeros. And I want to put some values into the right of the 0. So these two zeros here really dictate what I have to do in my table of values. So as you can see, your table of values this time is going to be a lot bigger than the past table of values. It has to be. And if I had another 0, let's say right here, then I'd want to fill in, I'd want to go over here. Look, you always want to go to the left and to the right of each 0. To the left and to the right of each 0. Okay? You want to use all the values in between, and to the right of your last 0, and to the left of your last 0. Okay? So my two x-intercepts are 0 and 4. So I'm going to put in x values to the left, x values in the middle, and x values to the right. Okay? And here it looks like this. Alright, there it is. Now look. Here's my 1x values. I put some values to the left. -3, -2, -1. And then there's my 0, which gave me out 0. Then the values in between these two zeros, 1, 2, 3. So I put in 1, 2, 3. Here's my 0, 4. 4. And it gives me out a 0. And I'll go to the right of the 4. 5, 6, 7. So I put in 5, 6, 7. So my x values are these x values, these x values, and these x values. Okay? I hope that makes sense. So let's graph this thing and see what happens, okay? Alright, 7 is going to be way up high. 7 will be way down low. 6 way down low. 5 way down low. 4 is going to be at 0. Okay? 3 is going to be at 9. So 7, 8, 9. 2 is going to be at 8. 1 is going to be at 3. 1, comma 3. 0 is going to be at 0. -1's at 5. And then -2's way down here. So this looks really weird. But if we'll just stop and think about it for a second, I think this is going to make some sense. Alright? So here we go. First of all, I know over here at 5, I'm way down at -25. So I know the graph's way down yonder. Like this, okay? Now I'm going to come up here. And it's going to hit here. And then start making its way down. Looks like it makes a little bit of a slight curve out. And then goes back down some more. Alright? Like this. Now, and actually I think I made a mistake, didn't I? Let's see. 1 is at 3. 0 is at 0. Yeah, I did. And -1's at 5. I apologize. When I plotted my points, I said -1 is at -5. And that's incorrect. -1 is at +5. So I know it's going to hit here. Sorry about that, guys. It'd be -1, +5. So I know it's going to come down, make a little touch here, and loop back up again. And then continue on like this. There we go. so I'm good there. It's going up to the left, and it's going down to the right. I did it. Guys, you can do these with practice. They're not that hard. Remember to always first list out your information. Second, find your x-intercepts. And then lastly, your x-intercepts dictate the values that you put into your table of values for x. Okay? Alright guys, I hope this video has been a help. If you have any questions, don't hesitate.